Welcome to Week 7, Video 7. This week we're going to look at the topic solving and graphing quadratic equations. Yes, we are graphing again. And we're going to actually look at the methods of solving, but first I'd like you to take notice to the picture in the upper right-hand corner. Standard form for a quadratic equation is y equals ax squared plus bx plus c. The first strategy we're going to look at is factoring and the zero product rule. Our first example for a quadratic equation is 2x squared minus 5x minus 3. That factors into the quantity of 2x plus 1 times the quantity of x minus 3. We'll set both of those factors equal to 0 and solve for x, and we get the solution negative 1/2 and 3. We normally put the solutions to quadratic equations in braces. And what these solutions are roots. We call them solutions, we call them roots, we call them zeros or x-intercepts. And these are actually the points where the parabola would cross the x-axis. The next strategy we're going to look at is the square root method. Our example is 2x squared minus 12 equals 0. I want to isolate the x squared term on the left-hand side, so I'm going to add 12 to both sides. Then I'm going to divide both sides by 2. Remember, these are equations, so you can, whatever you do on one side, you have to do on the other side to keep it balanced. That gives me x squared equals 6. Now I take the square root of both sides. And when you're taking the square root on these, you want to take into consideration the positive and the negative. Normally, we only use the principal square root, but we're going to use both of them for these answers. Again, I put my answers in braces, and I would probably approximate this if I was graphing so I knew where to put the vertex in decimal form. Our next example is 2t squared plus 12 equals 4. The first step is to isolate the t squared on the left-hand side and divide by 2. I skipped a couple steps there. I hope you're okay. I'm taking the square root of both sides. That gives me the answers of plus or minus 2i. Remember that the square root of negative 4, we cannot leave that radicand as negative 4. We have to bring the negative out because that's negative 1 times 4. Negative 1 is I, so you bring that out. And 4 is a perfect square, so we have two answers, plus or minus 2i, and they are non-real solutions, which really means that the parabola is above or below the x-axis and never crosses the x-axis. Completing the square is a method that I actually really like, and I use it all the time. I'm going to take the equation x squared plus 10x equals 4. And what we're trying to do is we're trying to create a perfect square trinomial on the left-hand side. So I'm going to actually rewrite my equation, leave a little space there so I can put another number in. To find what the term is that will make the left side a perfect square trinomial, you use the formula b over 2, the quantity squared. My b is 10, so I take 10 divided by 2, which is 5, square it, and my perfect square term I'm going to add is 25. I'll add 25 to both sides. Now, as you can see, I have a perfect square trinomial on the left-hand side. I'm going to factor that, combine my 4 and 25 on the right side, and now I have the quantity of x plus 5 squared equals 29. I'm going to take the square root of both sides, and remember that when you take the square root, you want both the principal and the negative square root. So now I have the quantity of x plus 5, because the square root canceled out the square, equals plus or minus 29. Subtract 5 from both sides, and my solutions, or roots, or zeros, or x-intercepts are negative 5 plus or minus 29. I'm going to continue a little bit more with some strategies, a little more completing the square. And this example we're going to use, as you can see, the leading coefficient isn't 1. We have 2x squared plus 2x minus 1. In order to use this strategy, completing the square, we need to have that leading coefficient equal to 1. So the first thing we're going to do is take the 1 from the left-hand side by adding to both sides. And now I'm going to divide each term by 2 to ensure that I have 1 as a leading coefficient. When I divide, my new equation is x squared plus x equals 1/2. Now I'm going to find the third term for the left-hand side that will make the left-hand side a perfect square trinomial. I'm using b over 2 divided by 2 and square that quantity. And my b is 1, so I take that 1/2, square it, that gives me 1/4. I'm going to add 1/4 to both sides. Watch these fractions. And now I have the quantity of x plus 1/2, the quantity squared, equals 3/4. Now I'm going to use the square root property, take the square root of both sides, and that gives me x plus 1/2 on the left. On the right, I have plus or minus the square root of 3 over 2. I subtract 1/2 from both sides, and my solution to this example is -1 plus or minus the square root of 3 over 2 in braces. My next example is x squared plus 10x plus 28 equals 0. I'm going to move that 28 to the right-hand side so that I can complete the square. And now my b is 10, so I'm going to divide 10 by 2, square it, and I get 25. Add 25 to both sides of the equation. And now on the left-hand side, I have a perfect square trinomial, which factors into the quantity of x plus 5, quantity squared. Combine my -28 and 25, and I get -3. Take the square root of both sides. On the left-hand side, that makes the square quantity cancel out, and I have x plus 5. On the right-hand side, I'll have plus or minus the square root of -3. I subtract 5 from both sides, and again, I can never leave the negative in the radicand. I bring that out as an I, and this is 2 non-real solutions. Let me remind you that non-real solutions just means that the parabola will not cross the x-axis. So let's look at a word problem using some of the strategies we're using. The square of 2 or more, the square of 2 more than a number is 64. Find the numbers. We're actually going to use a direct translation and write this in algebra. Translate x as the number, the square of 2 or more, so I have x plus 2, quantity squared, then a number is 64. Remember that is always means equals, so the equation that I'm using is the quantity of x plus 2 squared equals 64. I'm going to use the square root property. That drops the quantity squared on the left-hand side and gives me plus or minus 8 on the left-hand side. Now I have to subtract the 2 from both sides so I can find my solutions, and my answer is -2 plus or minus 8, and my solutions are -2 plus 8, which gives me 6, and -2 minus 8, which gives me -10. This is easily checked by putting -10 back in the original equation that I have. I'd have -10 plus 2 quantity squared, does that equal 64? And as you can see, it does. I also must check the 6. Now I have 6 plus 2 quantity squared. Is that equal to 64? And as you can see from my work, you can. On this actually, this is not the last slide, so don't get excited. We're continuing with some strategies, and we're going to use the quadratic formula. The quadratic formula is actually a form that you can use on any trinomial, any quadratic trinomial. And I actually have seen a lot of you try that in I think the last homework. Sometimes that's easier, sometimes it's harder, but I'm going to show you a problem where we're going to solve by both methods. You will be asked in your homework to use two different methods so that I can see that you understand that no matter which strategy or method you use of solving, you are going to get the same zeros, roots, solutions. So our example here is x squared minus 5x minus 14. I can factor that. I'm going to solve this again by factoring and the quadratic formula. I get x minus 7 and x plus 2. Set both of those factors equal to 0. And my solution is negative 2 and 7. Now I'm going to use the quadratic formula to solve this. In order to use the quadratic formula, of course, I always rewrite the quadratic formula. This formula is one that seems to slip out of my mind very easily. So my example is x squared, just like above, minus 5x minus 14. I need to know what my a, b, and c are. My a is 1, my b is negative 5, my c is negative 14. Now I can plug that all into the equation. I have the opposite of negative 5 for my b, for my negative b, plus or minus the square root of negative 5 in parentheses squared, minus 4 times 1 times negative 14, all over 2 times 1. Simplify that, and I get 5 plus or minus the square root of 25 plus 56. Watch your signs, especially in these. It's very easy to make a mistake with the signs that we're going to be using. I simplify the radicand, and I get 5 plus or minus 81 over 2. 81 is a perfect square. I know you have those memorized by now. And my answer is 5 plus or minus 9 over 2, which gives me 5 plus 9, which is 14 over 2, or 7, exactly what you saw in the solution when you factored. And 5 minus 9 equals negative 4 divided by 2, and I get negative 2. This is just a little proof for you that no matter which strategy you use, you're going to get the same solutions. And remember, I think I said it already, you're going to use, on some problems, I'm going to ask you to use two strategies to prove that to yourself. Please follow directions. And last but not least, again, your favorite, we're going to graph. And I have a couple graphs set up for you here. Letter A, I'm not sure if you can see that y equals x squared. That's my equation for this parabola. And this is a parabola in standard form. The vertex is 0, 0. The axis of symmetry is on the y-axis, so the equation for the axis of symmetry is x equals 0. You will need to do all of this in the homework assignment. Next, I'm going to set up a method to find some points on the parabola so that I can graph it. Before you start your table, look at your vertex, and since your x is 0, you need to select some x's above or below, above and below that 0, so that you get both sides of the parabola. As you can see in my table, I have several above and below 0. I'm going to plot those points and make sure all the points are labeled. Now pay careful attention to my graph. My x and y axes are labeled. I have arrows on my parabola. My points are all labeled. My axis of symmetry is labeled. My vertex is labeled. And that takes us to our second example, letter B. The equation for this graph will come up in just a moment. I want to talk to you about the vertex. You'll know the vertex here is 0, 2. There will be some questions where you have to figure out the vertex, and I have the formula coming up very shortly. But now our vertex is 0, 2. Our axis of symmetry is x equals 0. The equation for this line I'm giving you at this point, you will be able to find that equation on your own. And now I know that my vertex is 0, 2, so I need some values above 0 and below. You will see that I chose -2 and +2. In this case, 3 points is enough. Sometimes you will need more. I'm going to plot those points, label those points, and now we're moving to graph C. The equation for graph C is y equals -1/2 x squared plus 2. Again, this is given to you, but you'll be able to calculate that with your homework this week. My vertex is 2, -1. My axis of symmetry, again, a vertical line at x equals 2. And now I'm going to set up my table with values above and below 2. So I use 2, 3, and 1. Find my y values, plot those points, paying very careful attention to graph etiquette. Now that you are pros at graphing, I will expect to see graph etiquette on every graph. So let's review what I'm going to look at. But first, let me give you the formula to find the vertex. The formula is -b over 2a. So once I have the equation, I take the b value, divide it by 2 times a, and multiply it times -1. Then I put that value back into the equation to find my y value, and that will give me my vertex. Now let's review graph etiquette. Please don't make me take off points or not count your graph because of poor graph etiquette. You know my rules. Please use graph paper and for all your graphs. Put all your work for the problems with the graph all on the same page, please. Label the graph with your equation. Label the axes. Label the parabola with the equation with arrows on the parabola. Points on the parabola. Show the method you used to calculate the points. I used a table in this case. Label any x or y intercepts if they're good, clear points. As you can see in letter B, some of the points are not real clear, so all I did was label the x-intercepts. Label the vertex and label the axis of symmetry. That is all for this week's video. Watch for the PS, and I'm really not understanding why some of you aren't even trying it. It's a bonus point. Go for it. Have a good week.